We now learn how to find the equation of a tangent to a curve at a point P. Now we can see here that we're given a curve which would typically have some equation, like y equals to f of x. And on this curve we have this point right here, which we'll call point P. Now the tangent to the curve at this point P is the orange line that we see here. And this line passes through point P and has the same gradient as the curve at that point P. And so the objective of this tutorial is to learn how to find the equation of a tangent looking like the one we see here. Now to do that, we're going to work through a couple of examples. So let's go right ahead and get started. As a first example, we're given the function defined by f of x equals to x squared minus 1. And we're asked to find the equation of the tangent to the curve at the point P along its length with coordinates 2, 3. Okay, well I'll start by moving this question to the side, like so, and now we can get started. The function that we're dealing with here is f of x equals to x squared minus 1. And although this isn't required, I like to make a quick sketch of what this function's curve actually looks like, so that I know what I'm dealing with. So if I quickly sketch some xy axes, something looking like this, x and y, this function's curve would be the curve with equation y equals to x squared minus 1. And that's a parabola, and it would look something like this. Now what we're after here is the tangent to this curve at the point P with coordinates 2, 3. So on this curve, that would be roughly this point right here. That's point P with coordinates 2, 3. And so the tangent would be this green line I'm making a sketch of right now, which passes through point P and has the same gradient as the curve at that point. Now it's very important to keep in mind that because the tangent is a line, it has an equation of the form y equals to mx plus c. That's your typical line equation. And so the first step in finding this tangent's equation is to find the value of the gradient m. So let's just write that. Step 1, we need to find the tangent's gradient. Now, since the tangent has the same gradient as the curve at point P, all we need is the derivative of the curve's function. That's the derivative of f of x, which equals to x squared minus 1. So let's go ahead and start with that. F dash of x, the derivative, will equal to 2x. And to find that, I've used the power rule for differentiation. Now remember that the derivative is sometimes called the gradient function. And the reason for this is quite simply that this function gives us the gradient of this curve at any point along its length. So at the point P, remember it has coordinates 2, 3, the x-coordinate is 2. So the gradient of the curve at point P is f dash of 2. And that will equal to 2 times 2, which equals to 4. And that's the gradient of the curve at point P. But since by definition the tangent has the same gradient as the curve at this point P, we can simply state that the gradient of the tangent is m equals to 4. And that's our first step done. We now move on to step 2. And in step 2, we find the tangent's equation. And to do that, we're going to rearrange the formula y minus b equals to m times x minus a to form, or to write, y equals to mx plus c. That's the tangent's equation. Now, you may not have seen this formula before, and if you haven't, do make a note of it now. Here's how it works. M is the gradient of the tangent, so we've just seen that m is 4. A is the x-coordinate of the point on the curve. That's the point P that the tangent passes through, so A is equal to 2. And B is the y-coordinate of the point, so B is equal to 3. In other words, all we have to do in step 2 is rearrange y minus 3 equals to 4 times x minus 2. Well, doing so leads to the following. Y minus 3 equals to 4x minus 4 times 2, which is 8. And now adding 3 to both sides of this equation leads to y equals to 4x minus 8 plus 3. Finally, we can state that this tangent's equation is y equals to 4x minus 5. And we're done. We now have the equation of the tangent to this curve at the point P with coordinates 2, 3. Now the good news is this two-step method that we've just seen will always work. And in fact, let's look at one more example to illustrate that. As a second example, we're given the function defined by y is equal to 3x plus 1 over x, and we need to find the equation of the tangent to the curve y equals to f of x at the point P along its length with coordinates 1, 4. Okay, well, I'll start by moving this to the side, like so, and we can get started. So in this case, the function that we're dealing with has equation y equals to 3x plus 1 over x. Now, you can go ahead and check with your calculators, but if we make a quick sketch of this, it should look something like this. I'll have my x and y axes, and this curve should look something like this. And now we're looking for the tangent at the point P with coordinates 1, 4. And that would roughly be right here on the curve. So I'll just add P with coordinates 1, 4. And so the tangent would be the line which will look something like this. It passes through point P and has the same gradient as the curve at that point. Okay, now to find this tangent's equation, we follow our two-step method again. Remember, that was step 1, we find the gradient of the tangent. Now, to do that, we use the fact that the tangent, by definition, has the same gradient as the curve at this point P. So we need the gradient of the curve, and for that, we need the derivative of the function that we were given, which was y equals to 3x plus 1 over x. So we need to find dy dx, the derivative. Well, keeping in mind that y can be rewritten as 3 times x to the power of 1 plus 1 times x to the power of negative 1, we can use the power rule to differentiate this, and we find that dy dx equals to 3 minus x to the power of negative 2, which we can rewrite as dy dx equals to 3 minus 1 over x squared. Now that we have the derivative, we can find the value of the gradient of the curve at point P. Indeed, at point P, with coordinates 1 and 4, the x-coordinate is 1. So to find the gradient of the curve at this point P, all we need to do is replace x inside dy dx by 1. So that would be dy dx equals to 3 minus 1 over 1 squared. That's equal to 3 minus 1. Finally, dy dx is equal to 2. And since the tangent has the same gradient as the curve at this point P, we can state that the gradient of the tangent is m equals to 2. And that's our first step done. We now have the gradient of the tangent. We move on to the second step, step 2, and remember in step 2 we rearrange the formula y minus b equals to m times x minus a to write y equals to mx plus c. And remember, m is the gradient that we just found, that was 2. A is the x-coordinate of the point along the curve, so that's 1. And b is the y-coordinate of the point, so that would be 4. So we need to rearrange y minus 4 equals to 2 times x minus 1. That's y minus 4, which equals to 2x minus 2. And finally, adding 4 to each side of this equation leaves us with y equals to 2x minus 2 plus 4. And so the equation of the tangent to the curve at this point P is y equals to 2x plus 2. And that's the final answer. We've just found this tangent's equation. And that's it for this tutorial. There we go, everyone. I really hope that helped. And if it did, please hit like on this video and even subscribe to our channel, because that really does help us. I'll see you soon.